Okay, YouTube, in this video we're going to be exploring what we call function notation. That is to say, as we continue to study functions, we're going to be taking functions that are written as y in terms of x and rewriting them using what we refer to as function notation. And often you'll see this as f of x here is equal to this function as opposed to y. So what I want to start with is this. F of x and y can be used pretty much interchangeably. They mean the same thing, except for we know that y is a function of x, so why not call it f of x or say g of x or h of x? But basically, we still have our input x, and our output is going to be considered to be this whole thing. And what we would read this as is f of x, but also this is my y value. So this is my y value or function value at x. So it makes it more convenient to look at this as saying, well, I can tell you your y value at any given x value by using this rule right here. So we would read this equation as f of x equals 0.014x squared minus 24x plus 8.8. So what I want to do is I want to find function values but start expressing them in function notation. So it says use this function that I've been given here to find f of 30. In other words, find the y value of our function when x is equal to 30. So here's what we'll do. We need to start by interpreting, sorry, I'm going to multitask here. Interpreting a function is what it really is, which you can think of a function as like an input-output machine. Essentially, you plug one thing into it, and it's always going to spit one thing out of it using this rule that we've been given here. So really, this is just the rule that tells our machine what to do to the input to get to the output. So I'm just going to go ahead and turn my machine on here, and what I'm going to do is I'm going to just type in this expression. So I have 0.014, and then I have in parentheses, we'll throw in 30 everywhere I see an x. X is equal to 30, so we have that squared. And it looks like minus 0.24 in parentheses 30. And then we're going to add 8.8 onto this. So what I want you to see is when we find f of 30, it just basically means, let's go substitute a 30 in for all of our x values. It looks like we get 14.2, which by the way is clearly written on our paper right here, 14.2. But what I want us to kind of recognize is what this means is when we plug 30 into the function, we get the y value at that x value. Or in other words, when we plug 30 into this function, we got 14.2 as an output value. So looking at this example down here, I give us some other function of x, and I want to evaluate it for each of the following. So it's really not f of -5 that I'm concerned with, but I do want to look at this as an example. When you substitute using what we call direct substitution, which is this method here, which basically just means that wherever I see an x, I'm going to directly substitute in our input value, which this is our input. We're going to go ahead and simplify this expression. In this case, we get -5 squared is a positive 25. -2 times a -5 there is a positive 10. We say plus 7. So looks like we get 35 plus 7 adding from left to right, which comes out to be 42. In other words, when we plug -5 into this function, we get an output value of 42. So these next couple of examples, what you're going to see here is this. Essentially, everywhere we see an x, we're going to plug in x plus 4. So let's be very, very careful here. We want to take out the x's, and we're going to make a direct substitution. So this direct substitution in this case is x plus 4. And this means that we actually have a little bit of simplifying to do here. So in the first instance, we need to take x plus 4 and square it, take it times itself. And I can go ahead and simplify this here. A -2 times a positive x would be a -2x, and a -2 times a positive 4 would be a -8. And we have this plus 7 still at the end. So simplifying this further, let's go ahead and FOIL this expression out, these couple of binomials. We had x squared plus 4x is plus 8x, and then plus 16. And then over here on the right, we had a -2x and a -8 and a positive 7. I'm going to go ahead and combine those out to be a -1 now. So our final expression should be x squared. Total x's, we have 8 minus 2 of those would be a positive 6 of those, and then 16 minus 1 would be plus 15. So this would be our final expression when we evaluate for x plus 4. And last but not least, when we plug in a -x, the same thing that we're doing here as we did in the last one. So we're going to directly substitute for all of our, this is a 7, x values here. We're going to make them -x. And this one's actually worth noting. We do this substitution with the -x a lot going forward. But basically, a -x times itself is always just going to be a positive x. But this -x here is going to make this a positive 2x. This will be a plus 7. So I want you to notice, comparing the original expression here to this expression, when we plug in a -x, essentially anything that had an even exponent on it or no exponent at all stayed the same sign. We had a positive x squared and a positive 7. But this middle thing here changed because we took a -x to the first power, which is -x, and we take that negative times the coefficient in front, which flipped its sign. So whenever you plug in a negative x, let's note this mentally now. Anything that has an odd exponent is going to be the only thing that changes. Everything else is going to stay the same. Cheers.